Hello, everyone. We're working through Chapter 12, Part 1, An Introduction to Statistical Methods and Data Analysis by Ott and Longnecker. All right, so essentially we're going to go through the framework of how the multiple linear regression model is set up. What we have is one observation for each person or thing that we're trying to study. That's our yi. So the first person, their response variable would be y1. And if our sample size has n people in our study, then our last observation would be yn. So we have y1, y2, y3, all the way down to yn. Now for our x's, we no longer have a single variable for x. Now we have multiple variables. So we have xi1 down to xik. So that means that for each person in our study, we're collecting k variables on those people. So we can set this up in matrix form. So every row in this case represents one person in our study, right? And every column represents a different variable. So the rows here represent the different people or things that we're studying, and the columns represent the different variables that we're studying. All right, so we can rewrite our multiple linear regression model y equals beta 0 plus beta 1 x1 plus ... all the way down to beta k xk plus epsilon in matrix form. All right, so essentially what we do here is we have our yi's equaling beta 0 plus beta 1 xi1 plus ... beta k xik plus the random error for the ith person, epsilon I, and we do this for I equals 1 to n. So what this means is that for the first person, we have y1 equals beta 0 plus beta 1 x11 plus all the way down to beta k x1k plus epsilon 1. That's for the first person in our study, or the first thing that we're studying. It doesn't necessarily have to be people, but for the purpose of this video, I'll refer to the experimental units as people. Okay, so y2 equals beta 0 plus beta 1. Now we have the second person. So second person, first variable, plus all the way down to beta k x2k, and then the random error for the second person. We keep on doing this till we get to the nth person in our sample, right? So we get beta 0 plus beta 1 xn1 plus all the way down to beta n beta k xnk plus the random error for the kth person. So when we want to go make predictions for all of these people, we could just create, we could do the same exact thing, but we're going to get the y hat ones all the way down to the y hat ends. We're going to put hats on all of our parameters. That's how we're going to essentially estimate the parameters. But once you have the hats and you're doing estimation, this random error disappears. And what that means is that essentially, if you have the actual value of x and the actual value of y, all the points don't lie exactly on a line. So we add or subtract some amount of error, right? But once you have the predictions, all the predictions do lie on a line. They're based on the predictions of all the slope parameters. So we're going to get our estimated coefficients. Those are the beta 0 hats up to the beta k hats. And we're going to plug in everyone's values of x to be able to get the actual prediction for our y hats. All right, so this is the matrix notation. This can be helpful to think about how everyone sets up in our study. And I hope to see you in the next video where we move forward with our multiple linear regression model.